Assalamu alaikum wa rahmatullahi wa barakatuh. How are you, everybody? Welcome back again. Today, inshallah, we're going to work in exercise 5F, differentiation of trigonometric functions. This is the continue about the topic that we did before. If you remember, in the previous topic, we're just working in differentiation of sine and cosine ratios and differentiation of their powers as well. Today, inshallah, we're going to talk about two things: using product and quotient rule respecting to sine and cosine, and then the rest of the ratios. In exercise 5, in the textbook, in question number 1, the question asks you to differentiate with respect to x. For example, if we're going to do b d by dx of x sine 2x. You know, the product rule is u v dash plus u dash v, or u dash v plus u v dash. So we have to name one of them as u and the other one is v. U is x and v is sine 2x. U dash, derivative of the x is 1 and derivative of v is 2. Remember, derivative of the 2x is 2 and derivative of the sine is cosine of 2x. Then vu dash plus uv dash, or the opposite. So the derivative is uv dash plus u dash v, which means vu dash 1 times sine 2x is sine 2x, and then x by 2 cosine 2x is 2x cosine 2x, and that's the derivative. If you apply that with the quotient rule as well, like h, d by dx of x squared over cosine x. Again, u is the numerator and v is the denominator, cosine x. U dash is 2x and v dash is negative sine x. Then, starting from vu dash in order, because the quotient rule is in order vu dash, remember to write v squared in the denominator, then vu dash minus uv dash. So cosine by 2x is 2x cosine x, and then x squared by negative sine. Remember, negative by negative is positive because you have a negative sign here and the negative sign with the v dash. So uv dash is x squared sine x over squaring of the denominator, cosine squared x. Then final answer, if you want to write in the simplest form, you take x as a common factor. Only x, you can take it as a common factor. So 2 cosine x left from the first term and 1x sine x left from the second term over cosine squared x, and this is the final answer. Okay guys, let's do question number 4 in the same exercise 5F. The question asks you for values of x between 0 and 2 pi, which means the range which is given to you is from 0 to 2 pi. Remember, in this part, the question said between 0 and 2 pi. If the question asks you to include 0 and 2 pi on the range, so you're supposed to say that in the question 0 to 2 pi inclusive, between 0 and 2 pi inclusive, which means 0 and 2 pi supposed to be in the range. But now 0 and 2 pi outside the range, out of the range. So we're supposed to work all the angles between 0 and 2 pi. 2 pi is 360 degrees. Anyway, the question asks you to find the x coordinates of the stationary points. Why? They never said that in the question, but they said gradient is equal to 0. Right? The question said find the x coordinates of points on the curve y equals to sine x to cosine 2x plus 1, which is the gradient is 0. So the gradient is equal to 0. So it's the same idea of the stationary points. What you're supposed to do first, you have to differentiate the function first. So this is u and this is v using product rule. or you can expand the brackets. For myself, I'll deal with them as a product rule. So u sine x and v is 2 cosine 2x plus 1. U dash is cosine x and v dash is 2x times 2 is 4. Cosine is negative 4 sine of 2x. Again, differentiation of 2x is 2. And you have 2 outside. 2 times 2 is 4. And differentiation of cosine itself is negative sine of the same angle. 1 is a constant and the derivative is 0. So y dash is cross multiplying vu dash plus uv dash, or uv dash plus u dash v. I will start from vu dash. So 2 cosine x cosine 2x plus cosine x. Good. Then sine x by negative 4 is negative 4 sine 2x sine x. Fine. Now, the main idea is to convert the whole equation. Remember, to equate it to 0, because the gradient is equal to 0. First point, we have to rewrite the equation again to be in terms of only one ratio, in terms of sine or in terms of cosine. Okay. Now, actually cosine, we couldn't do anything for that cosine because I know sine here is related to the sine of the double angle. So let's keep the cosine to x as it is. See, 2 cosine x cosine 2x. We're going to decide about that later on. Plus cosine x minus 4. Sine of the double angle is 2 sine x cosine x multiplying sine x equals to 0. Then 2 cosine x cosine 2x plus cosine x minus 4 times 2 is 8, and sine by the sine is sine squared x cosine x equals to 0. Now we have to write the whole equation to be in terms of cosine. We can change sine to be in terms of cosine, and we have to change cosine with a double angle to be in terms of only cosine. Cosine to x has 3 identities, 3 formulas. We're going to use the one which is in terms of only cosine. 2 cosine x by 2 cosine squared minus 1 plus cosine x minus 8 by 1 minus cosine squared by cosine x equals to 0. You need to expand the brackets, and even here. And remember, I have negative 8 outside. 2 by 2, 4 cosine cubed x. 2 cosine by negative 1, negative 2 cosine x. Plus 1 cosine x. Negative 8 by 1 by cosine is negative 8 cosine x. Negative 8 by negative cosine squared by cosine is positive 8 cosine cubed x equals to 0. Now 4 plus 8, 2 like terms. By combining them, 12 cosine cubed x, negative 2 plus 1 minus 8. Negative 2 plus 1 is negative 1. Negative 1 minus 8 is negative 9 cosine x equals to 0. You're supposed to take cosine x as a common factor. You're supposed to take cosine x as a common factor, or you can use the calculator mod 3,4. Mod 3,4 is the cubic expression factorizing. So if you take cosine x as a common factor, then you'll have 12 cosine squared x minus 9 equals to 0. Anyway, you'll find 3 values of x. 3 values. X, or cosine x equals to 0. Cosine x equals to, because cosine squared is equal to 9 over 12. It is supposed to take the square root of both sides. Then you will get 2 values, cosine x plus or minus 9 over 12 in the simplest form is 3 over 4. So it's root of 3 over 2. And the other value of the x. Now let's remove the negative. So cosine x is equal to negative root of 3 over 2. Based on the range, this is the range. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Cosine x is equal to 0. We have two angles in this range will give you cosine equal to 0, which is pi over 2 and 3 pi over 2, 90 and 270. Remember, I told you you have to make the equation or set the calculator to be in the radian form, radian notation. Inverse cosine of 0, the answer is pi over 2. So two angles will give you cosine equal to 0. Pi over 2 and 3 pi over 2. These are the two angles. Now, for root of 3 over 2 and negative root of 3 over 2, cosine positive in the first and fourth and negative in the second and third. So this is theta, pi minus, pi plus, and 2 pi minus. X equals to inverse cosine of root of 3 over 2. Inverse cosine of root of 3 over 2 is equal to 30, which is pi over 6. Then, based on the given range, x is equal to pi, because cosine positive, in the first and fourth, pi over 6, and 2 pi minus pi over 6. So the angles are pi over 6 and 11 pi over 6. Here, cosine negative, second and third. Second and third, so the range or the reference angle is still pi over 6. So we're going to use pi minus pi over 6 and pi plus pi over 6. So the angles are 5 pi over 6 and 7 pi over 6. So we got 6 angles that will give that equation gradient equal to 0. Here we go again, guys. Let's do question 6. Find the value of the x, find x between 0 and pi. So this is the range for which e power of negative x cosine x is stationary. So stationary means gradient equal to 0 or y dash equals to 0. Again, product rule, u and v. Y dash equals to u dash v plus uv dash. E power of negative x and v is cosine. U dash is negative e power of negative x, v dash is negative sine x. So u dash is vu dash plus uv dash. Negative e power of negative x cosine x minus e power of negative x sine x equals to 0. You'll take negative e power of negative x as a common factor, then you have cosine x plus sine x left equals to 0. So once negative e power of negative x equals to 0, and from here x has no value, because if you decide to take len, remember there is no len of 0. For this part, cosine x equals to negative sine x, which means by dividing sine by cosine, you will get 1 equals negative tan x, which means tan x is equal to negative 1. Tan x is equal to negative 1. So using the range which is given to you 0 to pi, we have only the first two quadrants, 0, pi over 2, and pi. First theta and then pi minus theta. X equals to inverse tan of 1, which is equal to pi over 4. Then x equals to, Tan negative only in the second quadrant. So you do pi minus pi over 4. Then x is equal to 3 pi over 4. Basically, this question, it has the same idea of question number 5. Exactly as you see, the same value, but the x, yeah, same value. But the difference between 5 and 6, in 5 you're supposed to use quotient rule, and in question 6 you have to use product rule. Here we go again, guys. Let's do question number 7 on the same exercise. Differentiate with respect to x, which means find dy by dx. For example, if we're going to do a, y equals to ln of x squared cosine x. Yes, derivative of the ln is derivative of what do you have inside, derivative of the expression over the expression itself. But what you're going to do first to make it easier, because into this case you're going to use product rule. We're going to split the ln into two parts, ln of the first plus ln of the second. So before you start to differentiate, you do ln of x squared plus ln of cosine x. Then by simplifying the first part, you just move the 2 before the ln. So y equals 2 ln x plus ln of cosine x. Now differentiate. Derivative of the ln, remember, is 1 over x. So 2 times 1 over x is 2 over x. Plus differentiation of cosine is negative sine x over cosine x. So y dash is equal to 2 over x minus sine over cosine is tan x. And this is the final answer. If you want to simplify it and write it with the common denominator, you just multiply denominator, because this is over 1. You just multiply, you do cross multiplying, so y dash over x, and 1 times 2 is 2 minus x tan x. Both of them right. If we're going to do question 7c, y equals to ln of 1 plus cosine x over 1 minus cosine x. Again, ln of dividing, it's like this question is talking about ln of multiplying. So ln of multiplying is the sum of two ln. Here's the rule: ln a plus ln b is equal to ln a times b. Same idea, ln of a dividing b is equal to ln a minus ln b. So by splitting the fraction, which is given to you with the ln, so y equals to ln of 1 plus cosine minus ln of 1 minus cosine, because each difference, it's ln of dividing, which converted to difference of 2 ln. So by differentiating now each part individually, the derivative of 1 plus cosine x is negative sine x over 1 plus cosine x minus derivative of the 1 minus cosine x is negative with the negative is positive sine x over 1 minus cosine x. By making common denominator, the common denominator is 1 plus cosine x and 1 minus cosine x, then using cross multiplying, negative sine x plus sine x cosine x, then 1 by cosine by negative sine is negative sine x and negative sine x cosine x. Directly these two terms will cancel each other. Then you will have negative sine x minus sine x over the denominator 1 plus cosine and 1 minus cosine. Negative sine and negative sine is negative 2 sine x. 1 plus cosine and 1 minus cosine, if we just multiply them, they are difference of two squares. So you will get 1 minus cosine squared x. And you know that from the identities that you have it from semester 1 and even from the last year in grade 11, 1 minus cosine squared is sine squared. And in the numerator you have negative 2 sine x, sine with the squared cancelled. Then you have the answer as negative 2 over sine x. If you want to simplify it more, remember sine x in the denominator is reciprocal of cosec. So 1 over sine is cosec x. So negative 2 cosec x. Again, these two answers are completely right. Okay, some of the rules that we talked about before, about the derivative of tan, derivative of cosec. We're going to write these rules one more time before we start in differentiation of the rest of trigonometric functions. So, d by dx of tan x is equal to sec squared x. d by dx of sec x is sec x tan x. d by dx of cosec x is negative cosec x cot x, and you have these rules on the textbook and will be given in the final exam in the formula sheet. d by dx of cot x is negative cosec squared x. Good. Now let's apply these rules using some of the proving questions. Basically, if you want to differentiate, prove the first identity, prove that d by dx of tan x is equal to sec squared x. Starting on the left hand side, d by dx tan x is sine over cosine, which means we have to use what? Quotient rule. So u is equal to sine and v is equal to cosine. Differentiation of sine is cosine x, and differentiation of cosine is negative sine x. Now let's use the way of the quotient rule, which is v squared in the denominator, vu dash minus uv. So start from here. Always you have to start from vu dash. So cosine by cosine is cosine squared x. Then sine by the sine is sine squared x. Remember you have a negative sign here, and in the rule you have a negative, so it's plus over squaring of the denominator, cosine squared x. Cosine squared plus sine squared, which we call the Pythagorean identity, is equal to 1 over cosine squared x, and 1 over cosine squared is sec squared x, which is equal to right hand side. Proved. Now let's do sec as well. d, prove that d by dx of sec x is equal to sec x tan x. Okay. Differentiation of sec is equal to sec x tan x, and we know that sec is reciprocal of cosine. So start from the left hand side. d by dx of 1 over cosine x. Here we can use quotient rule and we can use chain rule as well by moving the cosine from the denominator and change the sign of the power. But I'm going to use the chain rule. I find it easier than using quotient rule. So d by dx of cosine power of negative 1x. Remember, you have to give the power to the cosine, not for the angle. Now differentiate. Move the power before the cosine, so it's negative 1. then reduce the power by 1. So it's negative cosine power of negative 2x. And differentiation of cosine is negative sine x. Negative by negative is positive. So you keep sine x in the numerator and you write cosine squared in the denominator because it has a negative power. We're going to split cosine into two parts, cosine x and cosine x, and you have only one sine in the numerator. Sine over cosine is equal to tan x, and 1 over cosine is equal to sec x, which is equal to right hand side. Let's do one more. I'm going to prove that d by dx of cot x, and you can do the other one by yourself, cot x is equal to negative cosec squared x. As we did with the tan, tan was equal to sine over cosine, but now cot is equal to cosine over sine. So you're going to use the inverse, the same rule, which is quotient, but you're going to use the opposite. U will be v and v will be u. Left hand side, cot is cosine over sine. Now u is cosine x, v is sine x. U dash is negative sine x, and v dash is cosine x. Then starting from vu dash, so square the denominator, sine squared x. Sine by the sine, or sine by negative sine, is negative sine squared, and then cosine by the cosine is negative cosine squared. This identity, you are familiar with it, which is sine squared plus cosine squared. I'll take the negative sign as a common factor, then you have sine squared plus cosine squared equals to 1 over sine squared x. Now negative 1 over sine squared x, and the reciprocal of sine is cosec, so it's negative cosec squared x because you have power of 2. So which means if you have negative 1 over sine squared, sine cubed, so it's negative cosine cubed, and so on, which is equal to right hand side. Proved. And that's it. Here we go again. Let's do question number 8 now on the same exercise. Differentiate with respect to x. For example, if we're going to do c, d by dx of 2 tan of 3x over 6. Now 2 over 6 is a coefficient of the ratio. So 2 over 6 is 1 over 3 in the simplest form. So you can write it outside. It doesn't affect at all in the value of the derivative. So d by dx of 2 over 6 tan of 3x. So d by dx of 1 over 3 tan of 3x. Keep 1 over 3 as it is, and derivative of 3x is 3. Differentiation of tan is sec squared of 3x. Then 1 over 3 times 3 is equal to 1, and the derivative is sec squared of 3x. If d by dx ln of tan squared of x, you move the 2 before the ln, because you know the ln derivative, not differentiation, not derivative, ln of any powered term or powered base, you can move the power as a coefficient. So it's d by dx of 2 ln of tan x. Keep the 2 as it is and start to differentiate. Ln, derivative of the ln, is sec squared over tan x. You can keep the answer like this form, or you can simplify it more. See, keep the 2 as it is. Sec squared is 1 over cosine squared, and tan is sine over cosine. So squared cancel cosine. It's 2 cosine in the numerator and 1 cosine in the denominator. Squared cancel cosine. Then denominator of numerator is going down. So you have 2 over sine x cosine x. Now, these two terms are part of the sine of the double angle. You remember the sine of the double angle? I'll just write it here. Sine of 2x is equal to 2 sine x cosine x. So here you have sine and cosine, but without 2. So you need to multiply both numerator and denominator by 2. So 4 over sine of 2x or 4 cosec of 2x. Now let's do question number 9. In question number 9, it's required to find equation of the tangent and equation of the normal. I'll do B. It's required to find equation of the normal to the curve y equals to tan squared x when x is equal to pi over 4. I told you before many times, if you want to find the equation of tangent and equation of the normal, you suppose to make sure you have three things: x, y, and the gradient. X, y, and the gradient. The point is, only x value is given to you, so you have to find y by replacing x on the function which is given to you. So y equals to tan squared of pi over 4. Basically, tan pi over 4 is equal to 1. So 1 squared is equal to 1. Now you have the y and you have the x. Now only one thing is left to make the equation, which is the gradient. Now you have to differentiate y dash or y prime. Move the 2 before the tan, so it's 2 tan power of 1, and differentiation of tan is sec squared x. Gradient of the tangent by replacing pi over 4, 2 tan pi over 4 sec squared of pi over 4. Tan pi over 4 is equal to 2. How do you going to write sec squared in the calculator? You're supposed to write it as the reciprocal, which is cosine squared pi over 4. So 2 over root of 2 over 2 squared. So it's 2 over half, which is equal to 4. Because root of 2 over 2 all squared is equal to 2 over 4, which is half. 2 over 4 is half, then denominator of denominator is numerator, so that 2 goes up. Now gradient of the normal is negative 1 over 4. Then the equation of the normal is y minus y1, which is 1, and the gradient is negative quarter x minus pi over 4. Now move negative 1 to the other side and expand the brackets. Negative quarter x plus pi over 16 plus 1, and you can keep it into this form. Or you can multiply the whole equation by 16. So 16y equals to negative 4x plus pi plus 16. And that's it. Here we go again. Question number 10. Find dy by dx in terms of y. You remember this question? We did the same idea in the previous exercise, and we did it even in the chain rule as well. Whenever they ask you the same idea, they're supposed to give you x as a subject and y as the variable. If you want to find y or differentiation of y respecting to x in terms of y, you're supposed to differentiate with respect to y, and then you're going to flip the answer to reach to dy by dx. For example, into C, x is equal to half cosec of 2y. X in terms of y. So we're going to differentiate x respecting to y first. Differentiation of 2y is 2, and then half times 2. Differentiation of cosec is negative cosec 2y cot 2y. Okay? Then 2 times or half times 2 is equal to 1. So dx by dy is negative cosec 2y cot of 2y. This is the final answer. Or dy by dx. I'm sorry, this is not the final answer. This is dx by dy. But you're supposed to do this step. Dy by dx is equal to 1 over negative cosec of 2y cot of 2y. This is the final answer. Or dy by dx. 1 over negative 1 is negative. Reciprocal of cosec is sine of 2y. And reciprocal of cot is tan of 2y. And this is the simplest form. Here we go again. Question 14. The question asks you to differentiate sec over cosec. I know you're going to think to use the quotient rule, which is completely right. But we can simplify first what do you have inside before you differentiate. Basically, sec is reciprocal of cosine, so it's 1 over cosine. And cosec is 1 over sine. Denominator of denominator is numerator, and denominator of numerator is denominator. So sine goes up and cosine goes down. D by dx of sine x over cosine x. Sine over cosine is equal to tan x, and differentiation of tan is sec squared x. Let's do this question. Question number 15. Show that len of tan half x is equal to 1 over sine. So basically, the answer could be into this form as well. Cosec x. Okay. Let's start from the left-hand side first. Differentiation of len is derivative of what you have inside over the function itself. Differentiation of half x is half, and differentiation of tan is sec squared half x. This is the angle. Divided by tan of half x. Half divided 1, you can move the 2 in the denominator, so you have half now by itself. Sec squared is 1 over cosine squared of half x, and tan is sine of half x over cosine of half x. Squared cancel cosine. Then that denominator goes down. So you have 1 over 2 and 1 over sine half x cosine of half x. Now by multiplying these two fractions, 1 over 2 sine of half x and cosine of half x. Now multiplying 2 by sine by cosine will give you sine of the double angle. This is half angle formula, by the way. It's 1 over sine double of half x, which is equal to 1 over sine x, proved, or cosec x equals to right hand side.